much. It's a pleasure to be here. Great to see you all. I guess you're second in the Tall American Speaker series today. So I'm here to talk about data journeys that we take as individuals and more often as institutions. I think that's where things get a little more interesting. So I want to first step back and look at the sort of wider context of what we're in the middle of, or actually I think in the beginning of, is this digital transformation of much of what we do in society, in our recreation, in our commerce, in our governments. We're adopting digital technologies at an amazing rate. And so this is really the result of 50 years of Moore's Law, giving cheaper hardware, software, storage for that much time, really gives us this tremendous capability that we're not yet fully taking advantage of by any means. If we were to stop the advances of hardware at where they are today, sort of in performance and economics, we could still spend many decades fully utilizing the hardware that we have in our society. We're just getting started. So it's an exciting time to be in technology. We are at the center of the dominant change of the century. So it's in many ways like mechanization was in the Industrial Revolution a few hundred years ago, but happening much faster and across a wider swath of society. So first I want to look a little bit at now at software in particular, data software, and where that's been changing recently. 10 years ago, we really had a dominant style of software that's very different than the one that's now available to you. We predominantly in enterprises used relational databases. If it wasn't in the relational database, it wasn't data. Now, there's nothing wrong with a relational database. It's an incredibly useful, powerful tool, but it's not the only useful tool. And as we now have greater quantities of data from more diverse sources, it can be limiting. Moreover, the methodology we used was rather limiting, and we tended to use a waterfall approach towards building software applications, where we would first get specifications and then design software to meet those specifications, and then implement it and deploy it, with each step following the other, and then it would be deployed, and the idea would be that it would run forever. We built a system to solve the problems of our business. In practice, this doesn't always work so well. You end up with systems which are hard to change and may not really match the needs. It's hard to anticipate what your real needs are, and it's also hard to design a solution that's really effective and get it right the first time. We've learned this through the years, that a more iterative style is a better way to approach things. So it was a system that it was a style that led towards these siloed systems that existed on their own, that were hard to modify and hard to really connect. So you'd end up with these different data repositories that couldn't be combined, couldn't easily be altered, and did the one thing that they were designed for moderately well. And so it was ripe for disruption. The demand was there. So I was very lucky to be working in a space that had never really adopted those methods or tools. I was working on search technologies, starting in the 80s and through the 90s, building search engines. We tried to use relational databases as an experiment to see how they would work as a platform for building full-text search, and ran into a lot of real issues in scalability and expense and so on. And it was just not a practical tool. So I started building systems that were completely outside the traditional enterprise realm. And this is Silicon Valley companies, which traditionally did sort of grow their own software. After a few years of this, I had a piece of software that I'd written on my own, thinking that I might someday sell it, build a business around it. And after having written it and sat on it for a few years, I realized I didn't have the stomach for business, didn't want to try to sell it. I just wanted people to use it. I wanted to see it help people find some value in it. This was some software called Lucene, search software. So in 2000, I started, as an experiment, just giving it away for free as open source. I dabbled in open source starting in the 80s, and so was familiar with it, but hadn't really ever gone into it as wholesale with a project. And I was thrilled with what I discovered, that not only was it adopted at a great rate, people would find it on the internet. I did no promotion. They would try it. It would do most of what they wanted, maybe all of what they wanted. They'd start using it, or they'd modify it. They'd bring their modifications back. And it was this really healthy dynamic of the software was getting better. People were adopting it without a lot of caution. I think when people think about adopting some commercial software, they're careful because they know they're going to be in some contractual relationship with a vendor, and they're going to build that dependency into their business, which makes their business more fragile. Whereas the open source, they could see how it worked. They could understand that perhaps they could maintain it themselves were this community to go away. But moreover, these open source communities last longer than companies in many cases. They're actually healthy organisms. So this was a huge lesson for me, that open source was a better way to develop software, develop it collaboratively among a much larger group of people, and build it for a more general purpose than it would be done for any one organization. And it gave you this huge advantage in terms of adoption. It was an accelerant, a sort of steroids for software adoption in open source. So I determined to keep working in open source. I then started this Nutch project trying to do web search as open source, a full-on Google or Bing style web search engine. I'd done web search before in the 90s, so I knew the basics. We ran into some problems getting things running smoothly in a distributed manner. Google wrote some papers about how to improve that. We implemented Google's ideas in Nutch, and that ended up being split out into this new project, Hadoop. I thought this would be useful technology for people building search engines, to have a more flexible platform, to be able to have a more iterative, exploratory development model, and also be useful for natural language researchers. That's where I'd gotten my start many years before, doing tasks like machine translation, speech recognition. I knew these were data-intensive tasks which were ill-served by the standard software tool sets, and that if you had software that could process petabytes at low cost on inexpensive hardware, that it would really be helpful to these communities that I was a part of. What I didn't imagine was that this would be so useful to so many other industries. that people in banking, in telcos, in government, in healthcare, in retail, in manufacturing, all these areas were themselves beginning to swim in data and finding the tools they had inappropriate, and finding that, at the very beginning, only a few of the very bold ones, finding that Hadoop was a better approach. Maybe not perfect, but better than what they had available to them. Scaled further, and encouraged a more appropriate, flexible style. So Hadoop really started to catch on. I didn't believe that it would spread outside of the search engine thing. Some folks started a company around that, Cloudera, to provide support for Hadoop. I joined a year later, sort of again as a gamble, figured why not, maybe this will pan out. And it's really, as we can witness here today, become now a mainstay style in enterprise software. So it was an important lesson that open source really can be used by enterprises. They will accept that, which is something I didn't believe coming into this. So now we have a very different environment than we did 10 years ago. We've on top of Hadoop, there's been a wide number of tools that have developed that are loosely coupled, that complement it. Some that replace parts of Hadoop with improved versions. You heard this morning already about Kafka. We've got Spark, letting you do all kinds of different computational models, and in a more succinct way than you could do with MapReduce. There's alternative storage engines to HDFS. So we've got this growing ecosystem of functionality, but which has this common thread of supporting a better model for development, where you can build sort of a minimum viable prototype, test it, find out if it's effective, and then improve it over time. Not be building silos, have one shared copy of data that multiple applications can use. So really providing the tools that are appropriate and are needed to capitalize on the kinds of data that we now have. Sensor data, data from network devices, the IoT data. We're seeing all these sources of data which really aren't transactional. And so a relational database isn't always the best tool. SQL might be still a good tool, and often is used. There's a number of SQL engines in this space, and a lot of people find a lot of value in that. But it's an option. You're not required to force everything through SQL if that's not what's needed. So I think it's a real opportunity for all of us to be able to pick and choose the right technologies and progress in a much more productive style than we're able to before. And we're seeing this pay off. Mark Andreessen wrote this article a few years ago now about software eating the world, where he talks about every industry really becoming driven by software, and every institution needing to, if it wants to control its fate, become a bit of a software development house. That is the way people are adding unique value to their businesses, is through software. That's the way they're gaining advantages over their competitors again and again. And more often than not, it's data software. So it's really come of age here. It's something that is, we're really seeing new generations of industry that are taking this to heart. We've got companies like Amazon reinventing retail, companies like Tesla reinventing cars, that are really built around data systems. And you may or may not, in every case, be fans of these companies that are doing this, but I think you can't deny that, that data is and will be at the heart of our businesses going forward. So it's something we need to take into account. So there's, this raises obviously some challenges. There's some of the challenges I think are not that deep. They're things that people fret about, and I think somewhat needlessly, people worry about having the right skill base. And I think, in general, folks can learn the new tools fairly rapidly. I don't think this is a deep problem, the skill gap. If you've got folks who have what's hard is to have people with a good knowledge of math and statistics, but if you've got that, which there is a decent percentage of society that has that, then you can figure out the tools to manage things. And the other harder thing to come by is industry knowledge, are the insights of where you can improve your business. That is what takes years to develop and grow. You can pick up a new technology in weeks, but being able to really understand where that is needed, where it can provide value in an industry, takes a lot more intuition that only comes with experience in that industry. So the hard challenges, though, I think, are more around actually changing our institutions to be able to take advantage of these technologies. People underestimate how structured most organizations are and how the culture is in many ways built around the technical choices they've made. How their IT is managed, how everything is, who owns what within the company, and to take full advantage of these new technologies really requires rethinking the organization. We really need to have, to take advantage of this, have people throughout an organization empowered to use technology to make decisions. It's not a central capability. The decision making needs to be, the power needs to be spread and made, so we need to deliver self-service systems. And this is hard. This goes against what decades of IT culture has built in most companies. And so this is one of the biggest obstacles that we find, is not that there isn't an opportunity in an organization, that they couldn't master the technology, that it's affordable. It's can their organization adapt to take advantage of these technologies. This is why we see a lot of times new companies that are growing so quickly, because they're able to start from the outset with this new kind of a culture that properly enables more people throughout the organization, in manufacturing, in sales, in marketing. Everyone needs to be taking direct advantage, or able to take direct advantage of these technologies. And so that's a more fundamental challenge. A related challenge is doing so ethically, maintaining the trust of your users, and not betraying that, because that's a hard thing to earn and it's easy to lose. And I think we're, as a society, only at the beginning of figuring out how to incorporate a lot of these technologies successfully. I think there's need for more regulation, and it's neat to see that we're actually starting to see tech companies themselves calling for regulation. And I think that's a new and, to me, heartening development, because if we're going to become the digitally enabled society that we ought to or can, and can get great benefit from, we're going to need to be careful to observe people's rights. And I think we all know of examples where that hasn't been the case, and that we're beginning to learn from. So I want to talk now about the journey that we all take in adopting these. I've seen a lot of people go through it. I've had my own journey through these things, and seen what is successful, what works again and again. And so I encourage you to not aim too high at the outset. You need to envision a future for your organization that does fully incorporate these technologies, but you can't get there overnight. It's a slow revolution, I think, is what we're finding is the most effective. A reinvention over time, that starting with small projects, that you can show clear success. Simple projects. There's a lot of excitement around things that are more complicated than you really need in the first instance. And it's better to start with something simple, get it successful, and then let that grow. In order to do that effectively, you need to have buy-in from the top. The senior management needs to believe this is the future for the company and permit these projects to happen. You need to also have the projects operate in an open manner so that as more people learn about them, they can join and share the systems, share the data. That's how you're going to get the benefit, and you can grow internally this competence. There's lots of use cases in lots of industries that we can show. It's a process, but I also want to, this picture reminds me that we also, it's tempting to do what we used to do and look for the perfect future organization and the perfect future systems. But it's important to remember we're never going to get there. It's not a matter of getting to perfection. Rather, it's a continuing journey. It's always going to be a journey. We're always going to be rewriting things, improving things, needing to throw things away. It's more like walking, where you're always off balance. And so I caution folks to not embrace any technology too tightly as a solution, as a standard, but rather always think about how will we be able to replace this with the next system? How can this integrate? How can we move forward? Because change really is the new normal in our systems. If we haven't learned that already, I hope we can agree on that now. So a little quick aside about sort of complexity of systems. There's a lot of excitement around people call it AI, machine learning methods, and I think people think, oh, we're going to do a big data system. We want to jump right in and do some AI because that's what's really going to help our business. And it might be the case, but I think there's a lot of simpler things which more often can be done more rapidly. Hillary Mason, it's one of my colleagues at Cloudera, likes to describe this what I think of as a hierarchy of kinds of data processing systems. You've got analytics, which is basically counting, and your data warehouses fall into this. And we're seeing people now deploying data warehouses at a huge scale where they couldn't afford to before. That's still an exciting thing to do. It may not sound like it, but it is, and I think it qualifies as big data. Then you've got data science, which is counting with some fancy stuff. It's fancy counting. So you've got a little bit more clever math going on in data science. It's fundamentally you're still counting stuff, but you've got to have a statistician on board too. And then you get to machine learning, which is really fancy counting with some feedback from the real world and some iteration based on that feedback. It's fundamentally nothing more than that. It's a fairly evolved use case. And you need to, before you can do machine learning, you need to have good data in hand. You need to understand that data. You need to know what it's telling you, what it's not telling you. You need to be able to diagnose whether you're finding what you want to find or something spurious. So I think most people are well advised to proceed slowly and not jump right into the deep end. But there's a lot of value, and maybe even greater value for your institution in building some easier systems first. So I encourage that, and it still counts as cool new big data stuff. Want to at least mention the cloud. I think cloud is a wonderful thing that enables these sorts of organizational transformations, because you can have a single shared, long-lived copy of data, of an institution's data, of all their data, but different parts of an organization can rapidly, on their own budget, bring up systems, experiment, develop, move into production. It's a good way to move away from some of the restrictions and cultural problems that a classic IT organization has. Now, you can also do the same kinds of things without going to the cloud. You can do it with a private cloud, or even just with your ordinary data clusters. But it really can make a lot of these things simpler and provide some real acceleration of your journey and of the transformation of organizations. So it's really happening, industry after industry. I've been at Cloudera now 9 years, and we've got customers in healthcare and telecom and retail, banking around the world who are deriving great value, whose businesses now completely depend on these data technologies. Now, even then, it's still they still got tons of siloed systems. They've got a lot of progress to make. As I said, even companies that have been early adopters are still making tremendous progress. It's rare to see a large company that's completely transitioned to modern technology platforms. There are a few, but most haven't. So it's a long road. I encourage you to jump in. It's not that cold. So in summary, we are at the beginning of the data age. We are now empowered to improve our institutions by getting data and understanding it, and using that to optimize our processes in every industry. It's a tremendously exciting time. You guys are all lucky, I think, I certainly feel lucky to be alive now and be able to be a part of this and see this transition take place. So with that, thank you very much. Hope your day is productive.